Hello everyone, in this video I'll be showing how to do hand simulation for a simple process. Here, parts are getting in to a drilling station and then getting drilled and then departing this small system. It has a queue associated with the process and it's a first in first out queue. Let's say an observer went in and observed this system for a certain time, and he saw that there were 7 arrivals. So he recorded all the arriving time and service time, and these all are in minutes. So let's go ahead and try to find how we can use this data to calculate some of useful statistics. The main idea of doing this experiment is to understand how ARENA works or any other simulation software works and generate those data, and we'll see eventually that we'll be doing this for just 20 minutes, and we'll see that there are a lot of bookkeepings that we need to do. So just imagine if you're running it for 30 days, it's going to be a lot of bookkeeping that ARENA or any other software does for us. So what I did is I just transferred this same data into an Excel file, and then from here we'll be getting some stat. The first thing we need to know is the inter-arrival time. What is inter-arrival time by definition? It's the time between two successive arrivals. So it talks about a pair of arrival, right? So part 2 is arriving at 1.73 minutes. When did part 1 arrive? At 0 minutes. So what is the inter-arrival time? It should be the arrival time of part 2 minus arrival time of part 1. So let's say part 1 in this system arrived at 0 minutes. And exactly after 1.73 minutes, part 2 will arrive. What is the arrival time of part 3? 3.08. What is the arrival time of part 2? 1.73. So I'll just subtract that. So part 2 arrived at 1.73 minutes. And exactly after 1.35 minutes after part 2 arrived, part 3 will arrive. So we can do it for all of it, but as Excel is smart, I'll just drag all the formula down up to here. Why we're getting negative? Because we don't know when entity 8 will arrive our system. So that's why it's negative. So we need to take it off. Inter-arrival time could be 0 or positive, right? It can't be negative. So we'll take this off. Next, we are gonna find the queue arrival time. In this system, we don't have any routing or we don't have any transfer time. So the time when they arrive the system, automatically that's the time they will be joining the queue. So we will just reference this column over here. I'll just drag. Next, the time it left the queue or the time it started the service. There is nothing in between. So instantly when a part will leave the queue, will join the service. So part 1, let's say at 0 minute, the drilling machine was empty. So it will straight away go for service. So at 0 minute, it's entered the queue and then it left the queue. System departure time, it's gonna be the time it joined the queue plus the service time, which is 2.9. Next, part 2 got in at 1.73 minutes. Before that, let me just drag this thing over here. So let me just write event time and then brief. And then number of parts in service and number of parts in queue. So we'll just track what's going on over here, because ARENA does this same thing for us, and this structure over here is known as event calendar. It just keep a track like what's coming in next. So at 0 minute, there was an event. What was the event? Part 1 arrived. Number of part in service. At 0 minute, part 1 joined the service. So we'll just write part 1 is in there, and then let me just make 2 more columns here. So number of part in service is part 1. So what is the number in service? It's 1. What is the number of part in queue? There is no part in queue. However, part 1 passed the queue. So we'll just write part 1 passed the queue. Okay. We'll like get through it slowly. Okay. Next event, when I'm over here at the 0 minute, I'll think that at 2.9 minutes the next event will trigger. So I'll write that event time, and then brief will be part 1 departs. Number of part in service at this time, I'll think like there will be no part in service. And then 0, and then number of part in queue, I'll think 0, right? Okay. And then I'll put another column, number in queue. 0. Okay. Next, at 1.73 minute, what happens? Part 2 arrives. And then what time it may join the service? The time when part 1 departs the system. So I'll just reference that here. And then what time it will leave the system? The time it joined the queue plus the time its own service time at 4.66. So we will write 2 more things here. So at 1.73, what happens? Part 2 arrived or joins the queue. And then number of part in service, we still have part 1 there. And then number in service, so I'll just write part 1. And number in service is still 1. Okay. Number of part in queue, part 2. Number in queue is 1. At 4.66 minutes, we are expecting that part 2, not expecting, actually it happened because I mentioned that someone collected the data for us. Part 2 departs the system. Number of parts in service? Technically no one, right? Okay. Number in service? No one. Number of parts in queue? No one. Number in queue? Like part 1 came in and then went through the queue. But right now there is no one in the queue. Okay. Next, what happens in the system? Part 3 arrives exactly at 3.08 minutes. When can it start the service? At 4.66 minutes. When it will leave the service? At 8.05 minutes. So we got 2 more numbers. One is 3.08 minute. What happens? Part 3 arrived. Okay. I'll just take this columns off. I think it's making it more confusing. Let's just track the event time and what part arrived and what part departed at that time. Okay. So 3.08 minute, part 3 arrived. What time it will leave the system? 8.05 minutes. So part 3 departs. Next, at 3.79 minute, part 4 arrived. What time it can start its service? The time part 3 can finish its service. What time it will leave the system? 12.57 minutes. Okay. So we got 2 more things. 3.79 minute. What happens? Part 4 arrived. At 12.57 minutes, part 4 will depart the system. Next, part 5 arrives at 4.41 minute. and then it will join the queue at it will join the service at 12.57 minutes, and it will leave the system at 17.03 minutes. So I'll write these numbers. 4.41 minutes. What happened? Part 5 arrived. Okay. Next, at 12 point, okay, let me just write this. At 12.57 minutes, part 4 will depart and part 5 will join the queue. So we already have that event here. So at 17.03 minutes, what will happen is that part 5 will depart. In between, there was another thing that happened. At 4.66 minutes, we don't have it. So at 4.66 minutes, part 2 departed. Okay, we have it. I'm so sorry. Okay, next thing what happens? Part 6. Part 6 is arriving at 18.69 minutes. When it will join the service? Exactly at this time, right? Because part 2 has departed the part 5 has departed the system at 17.03 minutes. So it will straight away join the service and then depart the system at 23.05 minutes. So I'll write this number, 18.69 minutes, part 6 arrived. And then part 6 will depart the system at 23.05 minutes. Part 6 departs. Part 7 arrived into the system at 19.39 minutes. What time it will join the service? When part 6 departs, and when it will leave the service? At 25.13 minutes. So I'll just write them. 19.39 minutes. What happens? Part 7 arrived. And then at 25.12 minutes, part 7 will depart. Okay. However, our total simulation time we are considering is 20 minutes. So whatever time stat is over 20 minutes, we are gonna discard. Before that, what I'll do is I'll sort this list over here, just so that we have all the time sequentially listed here. So smallest to largest, and now I have this list, and I know what happened exactly at that time. And as I mentioned that I'll stop whatever happened after this, so I'll just highlight it in red. So we are not gonna use this in our calculation. Okay, so I have my event calendar here. Let me go back over here. So one more useful thing is, based on these values, we can find the total waiting time of individual parts in the queue. How we can get that? The time it left the queue minus the time it joined the queue. And then, so let's do it for part 2. Part 2 left the queue, joined the service at 2.9 minutes. When did it started queuing up? It's joined the queue at 1.73 minutes. What about part 3? So it joined the service at 4.66 minutes, and then it arrived into the queue at 3.08 minutes. So that's how I'm gonna do it up until part 6. I'm not gonna do it for part 7. Why? Because at 20 minutes time, part 7 hasn't completed its queue time yet, because still it's in the queue. At 23.05 minutes, it will leave the queue. So we are not getting this stat here. We are not getting the number here for this. So I'll just highlight it in red. So based on this, let's go ahead and try to calculate some output statistics. Okay. Let's say average waiting time of parts. What it would be? It would be simply the average of these numbers here, which is 2.53, and let's just say minutes. So this is unit, this is value, and this is stat that we are collecting, and this is our output table. So I'll just label it as output table. Yeah, and I missed a E. Okay, I'll put E over here. So this is the average waiting time of individual parts in the queue. Next, we can find one more thing. The number of parts past the queue. How many parts past the queue? 6, right? So I'll just count this list over here. So 6 came in and passed the queue. Though part 1 didn't stay in the queue, but it came in and went through the queue. That's why we added it into this list. And this is count or units. Next, we are going to find the total system time for individual part. We can do it in 2 ways. One, we know the departure time of a part, right? And we also know the arrival time of a part. So we can just subtract them. So this is the total system time of parts. And I can drag it up to here. Look over here. I didn't do it for part 6. Why? Because part 6, we leave the system at 23.05 minutes, which is more than 20 minutes. So I didn't, I know exactly at what time it left the system. However, I'm not gonna add that in my stat because my simulation run is ending exactly at 20 minutes. All right, so that way you can find the total system time. System departure time minus the arrival time of a part. Another way to do it is, you know, the waiting time of a part, right? Over here. So if you add the waiting time with the service time of a part, you know that's the total time they spent in the system, as there is no other system process or anything going on. So you can find it in that way as well. I'll just drag them up to here. See, they're exactly the same. So you can find it subtracting system departure time from the arrival time, or you can add up the waiting time and the service time to get the total system time. So I'll just take off this row. Next, I'm gonna get the average of the total system time. Okay, so average total system time, or total time in the system, or cycle time, anything. Not anything technically, it's like you can call this stat as total time in the system or cycle time. Okay, average. I'll get the average of this list. What is it? 6.44 minutes. This is in minutes. So number of parts past, let's say completed the service is how much? How many? 5, right? Not 6, because part 6 is still in the service when we stopped our simulation run. So I'll just count them. Count this list and I'll put it here. Units. So through this hand simulation, we found these statistics values. And then we found the event calendar, like how the events are being scheduled. Next, we can find the utilization of our drilling machine. That's the resource in here. And we can also find the time average number of parts in the queue. For that, I'm going to pull up a PowerPoint where Simulation with Arena, which comes with Simulation with Arena textbook, they have created a visual context of this thing, which will be a little easier to explain how we can find the utilization of resource and the time average number of customer in the queue. So I'll just bring that PowerPoint here. I'll just maximize it. Okay. So over here, we can see what we have. So this is our system. And this yellow box over here is our drilling machine, suppose. This is the event clock. BT means number of resource busy at time T. QT means number of parts in the queue at time T. Arrival time of customer in the queue. It's just tracking the number of arrival time. Event calendar, the one that I showed in Excel. The number of completed waiting time in queue. This is mostly like number of parts which passed which passed the queue. Total of waiting time in queue. It's like an accumulated number, accumulated count. Area under QT, area under BT. So these are two graphs that we are going to do. So on x-axis it's time. On y-axis for QT is number of parts in the queue at that time. And BT graph on the y-axis, it's number of resource busy at time T. It's not resources because we just have one machine here. And here is the input data. Service time, and instead of arrival time, they listed the inter-arrival time here. And we have seen like how easy it is to find the inter-arrival time. Okay, so this is the setup of the hand simulation. Next, like any programming language, Arena also needs to initialize its system. So it initializes at time 0. And over here we can see there is no one in the queue because part 1 has not yet arrived. So in event calendar, we can see that the next event is gonna be arrival of part 1 at what time? At 0 minute. And what kind of event it is? It is arrival. So see over here in Excel, we did similar kind of thing. At what time the event will happen? The event occurred. What happened at that time? So exactly similarly, they put it over here. Next, it says dash 20 end. That means at 20 minutes, this whole system, this whole simulation run will end. It doesn't know yet part 2 is coming at 1.73 minutes. That's why it's not in the event calendar. Okay, I'll go ahead and go to the next slide. So at 0 minute, arrival of part 1 occurred. So part 1 came in and then sees the resource. Clock is 0, BT straight up went to 1 because part 1 is in the service. That's why it's 1. QT is 0 because it came in and it just passed the queue. Arrival time of customer in the queue is 0. Here, the next arriving time is 1.73 minutes and it's an arrival. Okay. And then after that, another event is scheduled, which is departure of part 1. Number of completed waiting time in queue is 1. Why? Because part 1 came in and passed the queue. The total waiting time in queue is 0 because part 1 didn't wait it in the queue. Area under QT graph is 0 because it's still here. See the red dot? It's still here. Area under BT graph, it's still 0. Though it increased to 1, but there is no area under it, right? There is no, we'll see it will eventually move on the right hand side. And then over here, it just ticks off what's coming next. Okay, next one. So what happens? Part 2, so the clock time is 1.73 minutes. Part 2 arrived into the system. BT is 1, QT is 1. BT is 1, why? Because it's processing part 1, which is here. QT1, why? Because part 2 just joined the queue. And this time over here is, so the time over here is 1.73 minutes. Okay, so at 1.73 minutes, QT increased to 1. Arrival time of customer in the queue, 1.73. Next, what is our next event? Departure of part 1 and arrival of part 3. Where it is getting this information? From the collected data. All right, it always keeps track of at max 3 events. Number of parts completed the queue is 1. Total waiting time in the queue is 0 because there is no area under this graph. So, or basically, sorry about that. This stat is simply saying that total waiting time in the queue. So some part 1 came in and straight away went to the service. It didn't spend any time in the queue. But part 2, as we have seen before, is going to wait in the queue. So whenever a waiting is complete, this value will change. Okay. Area under graph QT is still 0. Area under graph BT is 1.73. Why? Because at 1.73 we have part 1 in our system. So it's here, 1.73. So this is the area we are talking about. This is the area we are talking about. Okay. Let's go to the next slide. At 2. So the clock time is 2.9. So at 2.9, part 2 entered the system. Part 1 departed. BT is still 1 because now it's processing part 2. QT is 0 because part 1 left the queue. Next event is arrival of part 3 and arrival time of QT is empty. Number of completed waiting time in queue is 2 because part 1 went through the queue, part 2 entered the queue, stayed there for some time. How long it stayed? 1.17 minutes. How we found that? In Excel. So part 2 entered the service at 2.9 minutes. Why? Because part 1 left the system at that time. Minus, when did it join the queue? When did it arrive? 1.73 minutes. So if you subtract this 2, you'll get 1.17 minutes. It's exactly the same value. It's exactly the same value over here. Okay. Next, we're going to see that area under QT graph is how much? 1.7 because this time it's 1.73 and this time over here is 2.9, the clock time. So this area is 1.17. BT graph area under the area under the BT graph is 2.9 because this is 2.9. It's like accumulating. Next, part 3 arrives and then join the queue. When did it arrive? 3.08 minutes. Still it's 2. Area under the graph still 1.17 because part 3 just joined the queue. Area under the graph QT is 1.17. Area under BT because part 2 is still in the service. That's why. So previously it was 2.9 and now it's 3.08. 08. Why? Because this is the clock time. And what we are doing is we are multiplying the x-axis with y-axis. Y-axis is 1 because this is like a rectangle, right? So it's like length times height or width, whatever you want to think about. So length times width or length times breadth. Next, part 4 joins the queue. We have the arrival time of part 3 and part 4. Next event is arrival of part 5. Number of completed part is still 2. That means part 2 is still in service. Waiting time still that. Area under the graph, it has increased. See, waiting time in queue and area under the graph is different. Waiting time in queue will change whenever a part will complete its queue time. But area under the graph, whenever parts are joining the queue, it will increase, right? Or it will decrease, depending on what's going on there. Area under BT graph. So, okay, all right. One more thing I messed up is area under the graph QT will always increase because it's an accumulated count. So no matter if part left the queue, that's fine. But whatever has accumulated over here, it will not decrease. Okay. And then area under the graph is 3.79 minutes. That's the clock time. So this is 3.79 minutes. This is this time, basically, over here. Okay. Next, we have part 5 arrived into the system. This is their queue time, and QT is 3. That means we have 3 parts waiting in the queue. And then area under the graph, it's just simply added all this area together. Area under BT graph, it's simply 1 times 4.41. That's how we are getting the area under BT graph. Next, we'll see part 2 departed the system at 4.66 minutes. So we have that here. Still the machine is working. However, we can see QT is now reduced from 3 to 2 because part 3 entered the service. And here number of completed waiting time is 3. Why? Because now part 3 has also completed its queue time. And total of waiting time, so in previous slide we saw it was 1.17, which was for part 2. Now what it did is it added up the waiting time of part 3 and waiting time of part 2 together. So waiting time of part 3, let me go back to Excel, is 1.58 minutes. And waiting time of part 2 is 1.17. So it's simply, so here it's simply 1.17, sorry, 1.17 plus 1.58. So if you add this two number here, you'll get 2.75 minutes. All right, I'll just take that off. Next, we can see area under QT graph. It has changed, right? It was 3.12 at 4.41 minute. Now it's 3.87 because we have a interval over here. And then BT graph is 4.66. Next, part 3 will leave the system. Part 3 left the system, part 4 entered the queue. So number of completed waiting increased from 3 to 4 because 4 part completed the queue time. And then total waiting, it added the time of waiting for part 1 plus part 2 plus part 3 together. And then area under the graph, so this is the area under the graph. Area under BT graph, it's 8.05 minute. Okay, next thing what will happen, part 4 will depart the system. Part 4 departed the system and there is no one in the queue now. And then it came down. And the number of completed part waiting is 5 because part 5 also completed the queue time. Total of waiting time in queue is 15.17 minutes because how we are getting it? whoever completed the queue increased this time. And area under QT is 15.17. These two things are same right now because it's basically how we are getting the area here, and there is no one in the QT. So let's see what happens. And BT is simple, like now at this time it's 12.57 minutes. So it's just like 1 times 12.57 minutes. Next, part 5 will depart the system. Okay, so at 17.03 minutes, the system is basically empty. There is no one in the service, no one in the queue, and no one. So as there is no one in the queue, the arrival time in the queue is empty. And then part 6 is expected to arrive after some times at 18.63 minutes. Number of completed part is 5. The total of waiting time in queue is same as before, but area under BT graph was 12.57 minutes. At this time, it increased because this is like at 12.57 minutes, part 5 entered the service, and at this time it left at 17.03 minutes it left the service. So it just increased. Next, we'll see part 6 got in and passed through the queue. Clock the arrival time for part 6. Next arrival is for part 7. Next event is for part 7 arrival. All right. And then number of completed waiting is 6 because part 1, part 6 got in and passed the queue. Total waiting time in the queue is 15.17. Area under QT is 15.17. Area under BT is still 17.03 because exactly at 18.69 minutes, the BT increased to 1, but the area is still 17.03. Simply just think like, what is the area over here? Then it will be easier to understand. And then we have something over here. Number of completed waiting in queue is 6, as same as before. The total of waiting time in queue, 15.17. Area under the graph, still 15.17. Area under BT is 17.73 because some time went off before part 7 arrived into the system. Next, the end of hand simulation. We know that part 6 and part 7 is still in the service, is still in the system, not service. 6 is in service, 7 is in queue. But we have to end our simulation run by this time. So let's see. So we have one customer in the queue, one part in the queue, one part in the service. And then the arrival time of this one customer in the queue is 19.39 minutes. What is the next thing that will happen into the system? Departure of part 6 and then arrival of part 8. But we are not bothered about that thing. The number of waiting time in queue is 6, right? Still, because part 7 didn't finish its queue time. Total of waiting time in the queue is 15.17 because part 7 hasn't finished its queue time. It didn't add up. And then area under QT graph changed because up to here it was 15.17, but at this time, from 19.39 minutes to 20, this is the accumulated queue time for part 7. The total didn't change because it has not entered the service, but area under QT graph changed. And then area under BT graph is 18.34. So now we got area under BT graph and then we got area under QT graph. So after finishing the simulation by hand technique, we can see average waiting time in queue. So total of time in queue. So if we go back and see into our slide, I'll just go back. The total waiting time in queue is 15.17 minutes. Let me go back to the one that has this. So total of waiting time in queue is 15.17 minutes. And the number of times in queue, that means number of part that completed queue is 6. So this is 2.53 minutes per part. So that's the waiting time. So exactly the same thing we found here. Average waiting time of part is 2.528, which is approximately 2.53 minutes. Next, time average number in queue. So how we can find that? Area under QT graph over final clock value. So area under QT graph is not 15.17, it's 15.78. So you just add all the area under this QT graph and then divide it over 20 because that's the length of our simulation run. Okay. Next, utilization of drilling press. Area under BT graph. So you add all the area under your BT graph, which is your number of resource over time graph, which is 18.34 minutes. It's not 20 because part 5 left the system at 17.03 minutes and part 6 entered the system at 18.39 minutes, I guess. Yeah, 18.69 minutes. So there is sometimes when the resource was empty, there was no part in the system. That's why it's not 20, it's 18.34. So how you can find utilization? Like any other utilization. So the time it was busy over its scheduled time or the simulation time in this case. And then we got 92 or 92% of the time within this 20 minutes, our drill press was busy. So this is this is the conclusion of this tutorial. We get to know how Arena keep a track of its clock, how it keeps track of variables like number of part which completed the service, number of part which completed the queue, the total waiting time of parts in the queue, the number of parts in the queue so far, and then the utilization as well. So just for this 20 minutes, it was quite difficult on our side to do. So just think about if we run it for 30 days or for long runs, it's very difficult to do by hand. So that's why we need simulation software like Arena. Hope you learned something from this tutorial and see you in the next video. Thank you.